let's look at different discount rates. So here I have discount rates ranging from 0 all the way down to 39%. At 0% discount rate, the net present value is $500. And where did we get this from? By using the payments we had at the beginning and adding that with the initial rate, which is 0%, and using these payments plus the initial payment. As the discount rate increases, notice how the net present value decreases. And we can see that here in the graph as well. With no interest rate, no discount rate, we have a high return. However, increasing that rate will give me a low return. So here we want to determine the internal rate of return. At what discount rate will the net present value equal 0? And we can find that out by using the internal rate of return function, which I have right here. Let's try this out by using the IRR function. So IRR, here we would have to use the payments, and that is all you would have to find out. You can also do different decimal places if you want to be precise. So here we have at 23.29%, the net present value is equal to 0. We can also figure that out by using the net present value, by substituting the rate with the internal rate of return. Net present value function. So here we're going to do the present value with this discount rate and these values plus the initial deposit investment, and see how this gives me 0. So at $0 we have a rate of return 23%. So what does this mean? Somewhere between 23% and 24%, the net present value of investment is 0. This rate is referred to as internal rate of return. The internal rate of return of a series of cash flow is the discount rate that sets the net present value of the cash flows equal to 0. So, if the rate that we are given is less than the internal rate of return, we would have a positive NPV. So remember, the internal rate of return at 23% was $0. So here we have a positive internal rate of return because the rate, the rate is less than, the internal rate of return. Okay. So if the rate is greater than the internal rate of return, we would have a negative NPV. Note the IRR is the compound interest rate you earn on an investment. Now that you know how to calculate the IRR function, which is right here, you can also be able to use the internal rate of return to make investment decisions. And using the IRR to make investment decisions, having internal rate of return greater than the rate is a good investment. But if the internal rate of return is less than the rate, you have a bad investment. Let's go see an example. Here we're using the internal rate of return to choose between two investments. This example both shows investment A and investment B at a cost of $650, but they both have different cash flows in a 4-year period. If you are using the IRR to make a decision, then you will choose an investment with the higher internal rate of return. So here we use the function of all the cash flows to get the internal rate of return. So here we see that investment A is actually better than investment B. Even though it's not by a lot, we will still choose the internal rate of return that will have higher value. Note this, when using internal rate of return to choose between two comparable investments, we should always choose the investment which has a higher internal rate of return.